Hey guys, and welcome to Functional Print Friday, and welcome back to my basement shop. So in last week's video, we ran all this piping for fume extraction down here in this shop, and this run comes over to this blast gate that we also designed that mounts against the joist, and this run over here splits off into two parts. The metallized section over there runs over to the laser cutter as a pickup, and then this one drops down, hits this other blast gate that we designed that mounts to the pole, and comes down and sort of ends here on my electronics bench to pick up solder fumes. But we pretty much left it at that. So what I want to do this week is start to figure out how we go from the end of this piece of 4-inch flexible hose into actually picking up the fumes out of the back of either one of these printers. And in addition to that, at the end of last week's video, I mentioned as we were testing this, and I was holding just a piece of paper towel here to show you guys how much air was flowing through this, that probably want to make some sort of a grate or something for the end of this, because I can imagine if something gets sucked into this, it could potentially make its way all the way to the impeller on the exhaust fan. So I think let's start with that. This should be fairly easy, and in fact I think we can actually use some of the geometry that we already designed from last week to get this done pretty quick. Let me show you. So this is one of the design spaces that I showed in last week's video, and this specifically is the piece that we designed to adapt from the 4-inch flex to one of the 4-inch PVC couplers or Ys or elbows. This lower portion here, 4-inch flex slips over top of this and then can get a clamp, and the OD of the top part here slips into, actually it's a light press fit into a 4-inch fitting. So it slips in the same as a piece of 4-inch PVC pipe would, and then just stays in place and allows us to adapt to the flex. We used, I think, 2 of these in different spots in last week's design. So what I was referring to in reusing this, I think we can basically just lop off the top of this and then create a piece that we can use as a modifier in Bamboo Studio. And that's exactly what I have done right here. So this is essentially just the bottom half of this, and then I have a separate piece in here that we're going to use as a modifier in Bamboo Studio. These are separate pieces. They don't actually touch or connect in any fashion. I just sunk it down in there to make it easier when we pull this into Bamboo Studio. So I'm going to export each one of these as separate STLs, and then we will import them together in Bamboo Studio. So let me do that, and I'll meet you guys back over in Bamboo Studio. And here we are over in Bamboo Studio, and it's asking me, do I want to import these as a single object with multiple parts? Because again, I've selected both of those STLs at the same time, and yes I do, because that's going to keep this aligned. So when I click on this, it appears as one piece, but if I go over to the Objects tab, you can see they are separate STLs, and if I individually click on one here, you can see I can actually move that around separately, but we actually want it right where it was. So if I click on just our modifier, what we'd want to do is change the type of this, because right now it's a solid object. So we're going to change type. We're going to make this a modifier, and the color changes, and many of you can already guess where this is going. We are going to, for this modifier part, turn wall loops to 0. We'll turn top shell layers to 0. Bottom shell layers to 0. And we'll set our sparse infill to honeycomb. And we're going to want to print this facing the other way, but that's okay. We can still get a preview here. Okay, so you can see what's happened there now is it's just taken that modifier section and just created infill there that will still be attached to the rest of the model for basically a grate without actually having to design all that geometry. Now, those holes are a little bit small, so if we go back to our modifier, see we're at 15%, let's try 12%. All right, that looks pretty good. So let's flip this around. We'll now highlight the whole object because we want the whole thing to move. Lay on face. And yeah, that's down on the bed now. We'll just slice it again just to make sure everything looks good. And we'll go line type. And you can see now how that is going to print. So that should get us essentially, this will now slip over, or actually slip inside the end of that 4-inch flex, and we'll have a nice grate there as a pickup for solder fumes. So I'm gonna print this out. I'll bring you guys back. Actually, before we do that, let me show you guys another way to do that, because now that I think about it, kind of cheated a little bit, modifying the geometry in CAD first and then creating the modifier also in CAD. Like, that made it really easy to line things up here in Bamboo Studio, but you might not have the luxury of doing that if you've just grabbed an STL from, you know, Maker World or some other site and you want to modify it. So let's actually start by bringing in the full geometry from that part from last week's video. All right, so here's the whole part. Let's flip this over first. Okay, now we don't want to do a modifier because there's no geometry down there to modify. Instead, what we want to do is actually add some geometry, which if we right click on this, we could do add part, and we could load a cylinder. Now let's change the color of this because it's going to be super hard to see. Let's change the filament. I believe we can center this right in here. Yep. Now we need to change the size of this. Might be easier to see from underneath. And I'm kind of looking for where it's just breaking the edge of the wall of our existing part. It's kind of tricky to see. Looks like maybe right there. And no, we don't want it to be anywhere near that high. Although, actually, I guess it doesn't matter. We could just change the position of it. So let's bring this guy back down. We actually want to sink this below the surface of the build plate because we don't want to print this geometry on the bottom. We only need part of it. We only need like maybe about that much of it. And same thing for our modifier, or well, not our modifier, our generic cylinder. We can change the position of that. Just bring that down to, let's see, where, I don't know, maybe it's about that high over the build plate. That's going to end up being the thickness of our grate. Now, if we take that solid piece in there, that generic cylinder, if we make the changes in here now, we set wall ellipse to 0, top shell layers to 0, bottom shell layers to 0. And what do we do? Honeycomb, I think it was 11 or 12%. Put 12% in there. See if that works. Yeah, that also gets us to the exact same thing, and we didn't do anything in CAD. We literally just worked with the imported geometry of the entire solid parts, or the entire solid part from last week's video. So there you go, that's another way to do it. Now I'm going to print this, and I'll bring you guys back. All right, our print is complete and came out really nice. I printed this on the Bambu Lab P1S, and this is printed in PETG HF in the dark gray color, which I love this stuff. Honestly, I think everyone loves this stuff. It's never actually in stock. So I will put a link to this down in the description of the video, but you're probably just gonna have to set up a notifier via email for when it's back in stock, and it sells out quick. So I think last time it came in stock, I just bought 8 rolls, so I am set up for a little bit, but let's go see if this fits. All right, this should be pretty tight. In fact, we probably don't even need a clamp on it. If I get started on there, kind of rotate it in. Yeah, like there is no way that's falling off on its own, so I think we'd probably be wasting a clamp to put one on here. But let me turn the air on. Yeah, that's flowing plenty of air, so I think we're in good shape there. And I like the size of the holes here in the grate. I think that's good. Anything that is light and small enough to get sucked into there, I'm not really worried about, you know, making its way up to the impeller. And anything heavy that either falls in here or somehow winds up in there, it's not going to make it any further than like right here, because, you know, just out of frame, this thing goes straight up for like 5 feet. So yeah, I think we're in good shape. I'm more worried about, like, if I open up a small package of stuff and I could see, you know, like the empty plastic bag getting sucked into here without the grate, I think that would make it all the way to the impeller and could cause a problem. And actually, for airflow, I bought something for this week's video to help demonstrate the airflow. Let me go grab it. So this is a little portable fog machine. There's tons of these on Amazon right now because I imagine Halloween's probably the most popular time of year for these. I did fill it up. I tried it. It seemed to work. Let me see if I can remember how to turn it back on. I think it's this button. Yeah, and then you can control the amount of fog with these buttons. I think we hold this one down, if I recall. We have to keep it straight up and down. Am I doing something? Let me move the tripod, get you guys a better view. All right, there we go. I turned out the overhead light and just have a small light on here to make it really easy to see this. And you can see, if we imagine this is my soldering iron, it's probably not going to put out anywhere near that much smoke, but you can see how nicely that's just drawing that air across and sucking it all up in our intake here. All right, let's move on to the fume pickup from the back of these two printers. Now, when I'm printing PLA and PETG, all these shutters open up and it exhausts air out of the back. Here, let me turn it on quick. And around the back of the machine, you can see that these slats have now opened up and it is flowing air through there. I have it set at 20%, so it's not moving a lot of air, but it is moving air. Problem is, and I didn't realize this last week when I set out to do this, this does not open up when you're printing, call it hazardous materials. Like, with PLA and PETG, these do open up, and even with those materials, I think it's a good idea to exhaust the fumes if you can. If you have a single printer or maybe even two printers running occasionally in your house with PLA and PETG, I don't think it's going to be an issue. I guess time will tell. It's probably a good idea to exhaust it if you can, but I think largely the science right now says not a huge deal. But do your own research, don't take my word for it. What I'm most worried about is other materials like ASA, ABS, nylon, and the other nylon derivatives. I really want to make sure we're exhausting those fumes. The thing is, like I said, I didn't realize these don't even open up when you're printing those materials. The printer itself tries to filter the air in the chamber to get rid of any of the contaminants that are, formed when you're printing. Now, we do have a pretty big opening up here in the chute on the back of the machine. Like, I could pretty much stick my index finger all the way into the machine up through the chute. So, I mean, some of the fumes are definitely getting out. So we got to figure out now how we're going to actually exhaust those fumes out of the back of this machine when this is closed. Now, I have been thinking about this ever since I realized that these slats don't actually open when we're printing those materials. And I do have a couple different ideas. We could just try and remove one or more of these slats. And in fact, I found someone else's video that had hooked up fume extraction to the back of their H2 series machine, and they just removed these two top slats. I'd prefer not to do that, because then we've left a pretty big opening in the back of this machine all the time. What I'd like to do is maybe see if we can get one of these slats out of the back without breaking it, and maybe we can model one of our own and put some vents in it. And then what I'm thinking, when we're printing, say, ASA as an example, if we have a small amount of vent holes in the back and we have this attached, all we need to do is just create a very, very small negative pressure or vacuum at the back of the machine. And even if we're just pulling a little bit of air, say, in from the chute, circulating through the machine, as long as we have, again, a very small negative pressure inside the printer, we should be extracting everything through even our small vent in the back. So let me get you guys on the tripod. Let's see if we can get one of these slats out without breaking it. I don't know if it's better to do this with this open or closed. I'm trying to kind of peek in here and see if I can see how this works. So it looks like there's like a little arm on the side of each one of the slats on this side that actuates it. So let's try getting this side out first. I really don't want to snap it. There we go. Not sure how that's attached. Oh, okay. All right. That actually wasn't so bad. Let's go over to the bench. All right, so here is the slat that we just pulled off the back of the machine. This doesn't look like it's going to be too hard to model. It's got a lot of really small features. I'm just noticing it looks like there's actually like sort of a recess here and an overhang here where maybe those slats kind of seal against each other. And that arm is pretty small. Although this is probably, I'm guessing this is injection molded in ABS. I mean, I don't see why PETG, or if we have to, ASA wouldn't be up to the task. So, all right, I'm going to grab my calipers. I'm going to get a bunch of measurements on this. I'm going to start drawing, and I'll bring you guys back. All right, and here is the initial design that I came up with for this. It was tempting to kind of try and model the whole thing, but I thought, you know what, we should probably stop and not bother trying to design the actual little arm that comes up that causes this guy to rotate back and forth. I figure let's stop here. Let's see how sort of this little inset lines up with the piece above or below, and same thing for this other end over here. I tried to measure these as accurately as I could, but there's two variables. You know, number one, I might not have measured it exactly perfect, and then number two, when we print it, because these geometries are so small, it doesn't necessarily mean that just because I've designed, say, for example, this length to be 17.35 millimeters, that we're really going to be at 17.35, because we're kind of coming down on a little wedge down here at the end. So the slicer is only going to get that as close as it can based on the line widths that it can extrude. Same thing for this step here, because again, these are so small. Like this, the width of this step here, it's only 0.5 millimeter. Same thing with the position of these guys. Not only do I not know for sure if these are exactly the pivot point for these shutters or slats or whatever we want to call it, but I don't know that the geometry is going to print exactly like that either. Again, the slicer is going to do its best to estimate this in layers, and then the printer is going to do its best to put down the plastic where we're asking it to. So let's just stop here. Let's print this one out. Let's see if this fits. And then we'll figure out how we actually want to vent this and model the, the arm that actually causes this guy to actuate. So I wanted to take just a quick second here and talk about how we're going to slice and support this part, because the geometry of the part itself is not necessarily that complex. It's just that the details are so small. As an example, this step only being 0.5 millimeter wide, and these axles, same thing, quite small, and they need to be reproduced fairly precisely. Otherwise, these slats are not going to seal against each other, and they are not going to pivot correctly on these axles reliably. So we can solve some of that just by going down to a low layer height. And I have it set to extra fine, so a 0.08 millimeter layer height. But support is where it's going to be a challenge. We really do want to put this face down against the bed. We want a nice, smooth, flat surface there with an even texture, because that's the part that we're going to see, and that's the part that's also going to seal. But take a look at this. Regardless of what way we position this, we're going to end up with a stepped overhang. So position like this side's going to print just fine. I mean, it might be a challenge to reproduce the small detail here, even at a low layer height, which is also going to give us a slightly narrower extrusion width. I guess, we could put a 0.2 nozzle in, which would be even better, but I think we could probably get away with the 0.4. But how are we going to have a nice smooth surface there? Like, we could support these axles on the end with regular supports and probably break them off and clean that off with some sandpaper, and I bet it would be fine. But we've got a pretty long, straight surface there that we need to reproduce very cleanly. So I mentioned last week about how I think the H2D is really, worth it from the perspective of working with multiple materials, if that's something that you need to do. And this is another perfect example of it. So I've gone to support for this part, and I've set the support raft interface to be PLA. So if we take a look at this, if I slice this, and I'm going to set it to filament here, because I think that's going to be a little bit easier to see, although, I made the part gray, so it was easier to see, because when it's black, it's just so hard to see. Now we don't have a tremendous amount of contrast, but hopefully you can see here this white, that's actually going to be PLA. Now again, not necessarily needed for the axles on the end, but we're using it as the interface anyway, so they should come up even cleaner. Because when you're using a dissimilar interface material, you don't have to have a gap. Like, normally supports break off easily because there's a small gap, which means your first layer in your actual part is probably not formed too well, because it's still kind of floating in air a little bit. But when you're using a different material for the interface, notice my top Z distance is 0. And actually, way back when I first did the video with TPU and PETG, I had to manually change all these. Now the slicer actually offers to do this for you when you select a different material as the interface, which is nice because you don't want a gap. So when this prints, like if we come down to this layer here, this is still standard support material, so it's going to be the same material that our part's going to be printed from. But now we get into interface layers of that other material, in this case PLA. And for example, see right there, that's that first layer where we have that long supported edge. There's no gap between those materials. It's tough to get this at just the right angle because this thing's actually so small. I don't know if I can do it here. Yeah, it's hard to see anyway, but there's no gap between that support interface and that first line of the solid part that we're trying to print here. So we should end up with very, very clean surface all the way down the length of that, because we're just extruding that PETG right on top of that PLA. So I just wanted to mention that because, I think you could probably find a way to do this, or with a lot of post-processing, get a clean print without a multi-nozzle machine. This is where multi-nozzle machines really, really excel in being able to mix materials like this to very easily and cleanly get the result that we want with a minimal amount of post-processing. So, all right, I'm gonna print this. I'll bring you guys back. All right, our part is done. And aside from my attempt here at using that same trick of just putting a modifier, I just made a rectangular modifier in here and used the honeycomb infill trick. Yeah, it didn't really work as well on this. I think because we're breaking through that curved surface and the slicer kind of got confused in a couple places. So we'll probably have to model in the honeycomb or holes or whatever we want to do for this guy manually. But that's not going to prevent us from seeing if this fits. So let's go back over to the back of the printer. All right, I turned the vent off. I think we still want to put this side in first. Well, that's a little loose. That probably needs to be a little bit bigger. I don't think the other one could be pulled straight out like that. It does fit in there. Does this side still come? Yeah, this side still comes out. So I think it needs to be a little longer. I think these pegs need to be longer. Let's see how the rest of it looks. Yeah, we're a little short down there at the bottom too. And it kind of looks like the whole thing is a little bit shorter than it needs to be. Yeah, you can see the gap open up over there. So, all right, we got some adjustments to make, but that's not bad for a first try. All right, so yeah, definitely some issues as it just fell out on its own. But, I think as a first try, we're pretty close. So I think I'm going to take a crack at modeling that little arm that comes up on this to actuate it. And we'll go ahead and adjust all the surfaces on this. We'll make the whole thing a little bit longer, make these pegs a little longer, maybe a little bit bigger too, because I don't think the original one slips through this gap up here. So I'm gonna work on that. I'll bring you guys back. All right, guys, I've been working on this for longer than I would like to admit because I really wanted to incorporate the vents into the part rather than trying to do them in the slicer, so we'd have a bit tighter control over exactly how these are placed. And I wanted to stay with honeycomb. I thought that looked kind of neat on the fume pickup for my soldering area. And you can see I started by making the adjustments that we needed to make on our original part. I increased the length of it a little bit, increased the size of the step, and increased the diameter of our axles, or whatever we want to call those. And then I duplicated that and took a crack at designing the actuator arm on this as well. And there's definitely going to be more work to do here. Like, I want to reinforce this at the bottom where it meets, but there's really no point in spending a bunch of time trying to finalize what everything's going to look like if we don't know if this stuff's in the right place yet. So one thing I did notice, first of all, I did measure the angle of this with a protractor from the original part, and I think I'm pretty close. What's really tough to tell is the position of this, because the original part, the design of that part is not exactly like what I have here, and it's injection molded, so they had different design considerations. So it's really kind of tough to tell where this starts because I can't measure it exactly at the bottom, and then of course it goes off at an angle right away. One thing I did notice on the original part, it seems to be that if you put something 90 degrees sort of up against this peg here, the top one, I gotta get the perspective just right, but the top one seems to line up in exactly the same position. So like if I set something that's 90 degrees, if I set this down on a flat surface and I put something 90 degrees here on that same flat surface and put it up against this one, this little peg up here rests against it as well. So I kind of use that to cheat a little bit and get the height of this. So yeah, we'll see. We'll probably take a couple attempts to get this just right, but I think it's a good starting point. So I'm gonna slice this, print it, I'll bring you guys back. All right, our print is done. You can see I got a little cute there with a little bit of multicolor just on the honeycomb part of the print. Let's see if this fits. I'm not exactly sure how this part needs to key in first. Of course, the tripod's kind of in the way here. I feel like I rotated it when I took the original one out. Yeah, there we go. Okay. Well, it doesn't move. Actually, it does have a little more play in it than the other ones do. We're closer on the size. I think I still need to make this a little bit wider. Go turn the fan on. All right, well, it opened up. It doesn't look like it's at quite the same angle as the other ones. It looks like it's opened up a little bit further, and there is still a little bit of play in there. Still a little bit of side-to-side play, too. I think we still need to adjust the size a bit, like the overall width and maybe even the peg size. Although this side doesn't pull out anymore now. So we're definitely closer. I think the length of the arm might be off. I think that's why it's not in the same position as the rest of the slats. So I'm gonna get this off. I'm gonna compare it to the original one again. Put you guys back over at the bench. All right, so here's the two side by side, and I think we're on the right angle. I think it's just the height is off a little bit. This guy looks like it needs to be a little bit taller to me on our print. So I'll measure these again. I'll tweak that, bring you guys back. All right, I am back with what I hope is our final design. So I adjusted the honeycomb a little bit by sort of getting rid of these end pieces here and then recentering it. I just think that that is visually going to look better than the original design, and I think our vent was plenty big enough, so I don't think losing any, sort of surface area here for the actual vents is going to be an issue. I softened this edge here. I adjusted the size of all the little axle points again, and most importantly, I adjusted the position of this. It's a little bit tough to tell. This one's definitely taller. I used actually a height gauge on my surface plate to get the height of the original part, and then dragged this back, the position here where it sits against that face, until we're back to that same point where these two align in the same plane here. So I think that's going to put us in the right place. Also reinforce the bottom down here where it touches. Probably don't need that. I mean, my guess is this is going to be plenty strong enough, unless something's actually like blocking the vent and forcing against it, but it doesn't hurt. That looks nicer anyway. So, all right, I am going to print this out and I'll bring you guys back. All right, I had some regular PETG that was red. I thought that might be a nice contrast on there. I think it came out pretty good. It's a little muted because we only get the one layer of it, and it's just black on top of that, but let's see how this fits. Ooh, yeah, that actually looks pretty good. And I think we're there from a size perspective. It looks like it's lining up really nicely with the other ones now. Let's crank this up to 100%. Wow, that moves a lot of air on 100%. Let me turn that back down. All right, we're back at 20%. It is nice and quiet now, but still moving some air. And I think we're there. I mean, it's got the same amount of side-to-side play as the one beneath it. The angle looks dead on to me. And I think that's going to be enough, but we can test that with that little portable fog machine. I can't get over how much air this thing moves when it's on high. I guess I've never actually had it on full blast. Almost like it should have a warning on it. All right, check that out. And yeah, I know this adds absolutely nothing to the function of these parts, but the idea popped into my head and I just had to try it. I mean, we already had the design of the slats done, so it was pretty much just a matter of superimposing the graphic over top of that and then doing the color in Bamboo Studio. And I'll show you guys how I did that. And I actually think it came out really neat. The red PETG sort of mixes with the black PETG and gives it this sort of like fading in and out look. Do notice we did have, must have been like a wisp of the black PETG got mixed in with the white there, maybe stuck to the bed before the white got laid down, but overall that came out pretty neat. Let me know down in the comments what you guys think. Are we in multicolored garbage land here, which I'm always saying we don't do on this channel, or was that worth the effort? Let me know what you think. And here's how I accomplished that in CAD. I started by just taking our original slat design with the honeycomb vents on it, and I just got rid of the honeycomb vents and then duplicated that 6 times and brought in the graphic that I designed for the jet blast. And the way I did the color on this is actually the same way that I did the color on the grate, which I just realized I didn't show you guys before. I take my designs, and if I want another part to be like a different color, or I shouldn't say another part, but if I want something within a given part to be a different color, I'll just take it and I just sunk this down 0.05 millimeters. The slicer is not going to try and interpret that as a different layer. Like it's still going to slice these two faces on the same plane, but it's enough of a difference that you can use the color tool with the edge detect in Bamboo Studio to change the color on this. And that's exactly what I did on the rest of these slats as well. They're just solid on the other side. And when I brought in my graphic and set it down across all these slats, and I've got a 0.2 millimeter gap between these. It's kind of guessed on that. It's really hard to measure the actual gap in these slats, but I sunk the design down 0.05 millimeters. And the outer part I colored in red in the slicer, inside part in white, and then I just left these other parts as black. So that's an easy way to color stuff in Bamboo Studio. And yeah, I'll just show you guys in Bamboo Studio quick how I did that. So here's those slats in Bamboo Studio. Now we'd actually want to set these down on their face for printing, but just for the sake of argument, it's really tough to see as we zoom in. If you sort of turn it sideways, you can see the difference. But when you click on this and go to the color tool, now I don't have all the filaments in here that I printed that with, but we'll just select black. If I go to fill and then set it to edge detection, you'll see as you hover over that, you can pick those parts. So I just went in just like this, selected all the parts, and then used, say, my other color. I guess that'll be enough of a contrast. We can see that on the inside here. And you can see rather quickly you can color that stuff. And again, when I go to slice this, that's all going to be on the same actual plane. Like it's not going to try and have these indented up above the build platform and, you know, not get a nice uniform surface. So there you go, another trick for your slicer toolbox. All right, guys, I think we're going to wrap up this week's video here. I know we didn't get to the point of actually testing this vent in this week's video. While this was printing, I did actually take a crack at a V1 design of a piece to actually fit over this and be a fume intake and adapt to our hose. There's a couple oddities here that I also didn't realize when I set out to do this last week. I assumed that these 4 holes here were either fasteners that could be backed out and used or threaded holes, and it's neither. They're just smooth holes into the plastic chassis of, well, I don't think the plastic chassis, they're probably holes in the housing for the fan, and then this metal piece just keys up against it. I did come up with a way to interface with this without causing any damage to the machine, but I broke my own #1 rule of trying to do too much in the V1 of a part, and there's lots of issues with it. I will tease it just briefly here so you guys can see I do actually have something, but we're going to have to come back to this next week because there is a lot of issues with this. It does not work for numerous reasons, so we'll come back to that next week. Guys, as always, thanks for taking the time to join me in the shop for this week's video. And hopefully you'll join me next week when we wrap this up. And also, a special thank you to my patrons for supporting all the content on this channel. I will put a link down in the description of this week's video to the Patreon if you want to check that out. I don't take any sponsorships on this channel, so the content really is pretty much just sponsored by your views and the support that I get from patrons. And if this is by chance your first time here on the channel, this is all we do. It's all functional parts and the design and engineering that goes along with that. Yeah, we did get a little bit into the weeds with the multicolored garbage this week, but again, let me know down in the comments. I think it was worth it. But if you like that sort of thing, you know, check out some of the other videos on the channel. And if you like what you see, hit the subscribe button. And guys, if you do, I'll see you next Friday.